Okay, today's lesson is over what's called systems of equations. Okay, systems of equations. Okay, we've done a lot of work on how to graph linear equations. Y equals mx plus b. Finding your y-intercept and then graphing the different points based off of your slope. We've spent the last 3 weeks talking about it. So y'all have repped it and repped it and repped it. At this point, you should know how to graph those lines. In order to solve systems of equations, it's imperative that you're able to graph those lines. All right, I'm going to show you some tricks on the calculator. And obviously, if you're watching the video, I can't put a calculator on the iPad, but I will walk you through how to use your calculator to solve a lot of these problems. Now, in a system of equations, all right, how many equations do you think we're talking about?
A system.
There's a system of them, but how many equations? Two, all right? Rather than just have one equation, now we're going to have two equations for the same problem. Okay? Now, what I want you to understand, let's go back on that. What I want you to understand is when we've graphed these straight lines like this, that line represents every answer for that equation, right?
Yes, sir.
Every point on this line, I could plug into my equation and it'll give me a true statement. Okay? So, if I took these two equations over here, these two right here, and I graphed these equations. The first one is y equals 3x minus 2. My y-intercept is negative 2, so I'm going to start down here. That's my first point. My slope is 3, which means I'm going to go up 3 and over 1, up 3 and over 1. And all of these points are solutions to that equation, correct?
Yeah.
When I connect those lines, all the points that touch that line are solutions to that equation. Now, when I graph the other line, y equals negative 2x plus 3. Now I'm starting at the plus 3, and my slope is negative 2, so that's down 2 and over 1. Down 2 over 1, as many times as I can. And now every one of those points is a solution to that equation. Okay, so I have two equations. I now have the solutions to both equations. What is the only solution that works for both lines? Where would I find that? Where they cross. Exactly. This point right here. At that point, that coordinate works for both lines. Right? It's the only point on this graph that we could plug into both equations and get a solution. So for the system of equations, that coordinate is our answer. Okay? That would be 1, 1. That would be our solution. Okay? Now, if I go to the next page, you can see they already have this one done for us. Okay? We have our two lines, our system over here. They've already graphed them. Okay? So this coordinate right here, that where they cross, that is our solution to the system. What's the coordinates at that point?
Up 7.
No, remember, you got to go to the mountain before you can climb it.
1, 2, up 3, right 1.
You're doing rise over run. I want the coordinate.
Oh.
You got to go to the mountain before you can climb it.
Oh, 3, 1, or 1, 3?
1, 3. So that's the solution to this system.
Cool.
All right, now,
All the coordinates.
and again, if you're watching the video, you're not going to be able to see this because I'm going to do it up on the board with the calculator. But I want you to see how we can use our calculator to solve systems of equations. Maybe. If it'll mirror. Okay, so on the screen, I have the calculator pulled up. All right. If you're at the main screen, it's just blank with the flashing box.
Wait, mine doesn't.
All right, now, please watch so you can see. Martin, watch. Okay, we have two lines that we want to graph. So if I click y equals, it brings me to the screen where it's got y1, y2, y3. All right, these are all the lines that we can graph. We're going to enter these two lines into my y equals menu. So I've got y equals negative x plus 4. And then I'm going to go down and I'm going to do my second line. Y equals 3x. Now we can hit the button on the far right that says graph and it'll show us those two lines. And you can see that it looks very similar to what we had talked about earlier. Now, just seeing these lines cross does not give us our solution yet, right? We need to know the point where those lines cross. So here's how the calculator can give you that point. We need to calculate where that happens. Now, do you see the trace button next to where it says graph? Above it, it says calc, right? Short for calculate. So in order to hit that calculate button, we have to hit second first. Then we can hit that trace button. It'll take us to the calculate menu. Now, looking at the different things we can calculate, which one do you think will show us where the lines cross? Intersect. We want to know where the lines intersect. So if you go down and select 5 and hit enter, it'll bring us to this screen. Now this is where it's weird. You have to hit enter 3 different times. Enter, 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 and then it tells you your solution. 1 and 3. X is 1, Y is 3. Okay. Now, again, I'm going to show you, if we go back to the first problem that we solved, we could go y equals, and we could type in 3x minus 2, and then we could put negative 2x plus 3. All right, and we can see the line that we graphed earlier. We say second, calculate, intersect, enter, and my solution is 1, 1. All right, so just like that, the calculator can solve all the problems for us.
Wow.
Okay. Okay. So, we can see here what they had here was 3x minus 3, and then they have this right here. Now, this actually equals 3x minus 3. So, we get two of the same lines. So, if I graphed y equals 3x minus 3, I'd get this line. Then if you graph it again, you're going to get the same line on top of itself. They're not parallel, they're the same exact line. Which means they don't intersect at just one point. They intersect at every point on the line, which means there are infinitely many solutions. You can just make the little figure 8 sign, and I'll know that you know that it's infinitely many solutions. Okay? Now, you brought up a good point. What if you do graph both lines and they're parallel? They're never going to intersect. How many solutions will it have? It won't have any solutions, right? The solutions are where it crosses. If they're never going to cross, then there are no solutions. So if you get a question where it's parallel, your answer will be no solutions. All right. Okay, if we look at this one right here, you can use a calculator, which is always nice, but I'm going to go ahead and do it by hand. Our first line is at plus 2, and then we have a negative slope, so we're going down 1 and over 1. Biggest mistake that 8th graders have been making this year is that they don't pay attention to the negative slope. Remember that negative slopes go down, not up. It's not the straightest of lines, but it'll do. Then we have minus 1, and this time we're going down 4 and over 1. Or up 4 and left 1. And we can see that we're going to cross right here. The coordinate for that would be negative 1 and 3. If you put it in your calculator, you would get negative 1 and 3. Okay. First line is negative 2x plus 5. So we start at the 5. We're going to go down 2 and over 1. Over and over and over. As many times as we can to make sure we get as straight a line as we can get. Alright. Then we're going to have y equals 3x. Now that starts at the 0. We're going to go up 3 and over 1. I can already see that it's going to cross right there. Alright, the point there would be 1, 3.
3. That was close.
Alright, now, let's talk about some of the tougher things that they're going to give us. Alright? Like a word problem. Alright. Here we have a word problem. Now it tells us that Keisha and her friends are going to go to the concession stand at the football game. Charges $2 for a hot dog and $1 for a drink. They're going to buy 8 items and it's going to cost $11. Right? They want to know how many hot dogs and how many drinks were ordered. Okay? So there's a whole bunch of information here that we've got to set up. What are the 2 things that we don't know?
How many friends she has.
No, I mean, yeah, we don't know that, but that's not what it's asking about. All right, what 2 things is it asking about that we don't know?
Where are the concessions?
Number of hot dogs and number of drinks. All right, so hot dogs and drinks. These are our 2 variables. All right, now we always use x and y. So we'll make x hot dogs and we'll make y drinks. Now, what do I know about the number of hot dogs plus the number of drinks? What is that going to give me?
Equal $3.
$3. So if I took the number of hot dogs plus the number of drinks, I'll get 3.
Oh, wait. What were you asking?
The number of hot dogs and the number of drinks all together. Am I asking? Shh. Am I asking how much it costs? Am I asking any questions over price yet?
No.
No. If I took the number of hot dogs plus the number of drinks, how many items do I have altogether?
No. 2.
Tells you in the word problem. You're not reading the word problem.
8.
It says there are 8 items. Everybody see that?
Yes, sir.
So the number of hot dogs plus the number of drinks is 8. All right. Now we can start to talk about the price. Okay? Each hot dog costs how much?
$2.
$2. So we're going to pay $2 for every hot dog. And then how much for every drink?
$1.
$1.
All right, so yeah, each drink is $1. So if I take $2 times the number of hot dogs and $1 times the number of drinks, how much is that going to be overall?
2 times.
How much is that going to equal overall?
Oh, $3.
Overall, how much will it equal? Price. $11.
You go, girl.
All right, so
You just repeated what I said.
now we have our 2 equations. Now here's the problem. These equations are not in y equals mx plus b form. We've got our x and our y on the same side. So here's what you got to do. We want to get rid, on this first problem, we want to get rid of that x. So we're going to subtract x from both sides. Okay? Now what that's going to give you, and I'm going to write it over here, we're going to have our y by itself. Now you can't actually subtract x from 8 because we don't know what x is. So we're just left with that negative x and the 8. So there's my first equation. Down here, I want to get rid of the 2x, so I'll subtract 2x from both sides. So that's going to give me my 1y is equal to negative 2x plus 11. Okay. So now we have our system of equations. Now, we can use our calculator to actually solve this. We could say negative x plus 8 and then negative 2x plus 11. All right. When you graph the line, you can see where it intersects. So we say we say second, calculate, intersect, inner. And you get that x is 3 and y is 5. All right, so how many hot dogs were there?
3 hot dogs.
And how many drinks?
5.
Drinks.
There we go.
That makes sense. Oh, never mind. I was say, why would somebody order 5 drinks but 3 hot dogs? Shout out to me.
All right, so let's do another example here. Same thing. This time we're talking about bowling and laser tag. How many times you go bowling, how many times you do laser tag. Now, he wants to play 6 total games. So, x plus y needs to equal 6. The number of bowling games and the number of laser tag games needs to equal a total of 6. Now, each time he bowls, it's $2. Okay, so now that we have it set up, we need to move it around again. Now on this first one, I need to subtract x from both sides. Okay, that will give me y equals negative x plus 6. I just subtracted x from both sides of the equation. On the left side, it canceled out. On the right side, we're just left with the negative x. Now, on the next one, I need to subtract 2x from both sides. That will leave me with 4y equals a negative 2x, because we can't actually do that subtraction, plus 20. Now, here's the problem. We have 4 y's. We only want 1. So in order to go from 4 y's to 1, I need to divide every single thing on here by 4. Because 4y divided by 4 is 1y. Negative 2 divided by 4 is just negative 1/2. 20 divided by 4 is 5. So here's my 2 equations. So if I graph these, all right, the first one starts at 6, and I go down 1 and over 1. That's my slope. Then I start at 5, and I go down 1 and over 2. All right, I can see that this is where it crosses, right there at 2, 4. So 2, 4 is my coordinate. So bowling,
2 times.
I misspelled bowl.
Coach, I misspell everything.
Bowling is 2, and laser tag
4.
is going to be 4. Now those are harder than probably anything you're going to see on a STAR test, but it is good to be able to set those up. All right, I'm going to do these last 2 examples, and then you're going to have homework.
Oh my God.
Okay, so again, on tonight's homework, you can use your calculator. I'm not going to use a calculator here.
Yay!
All right, so just follow along. First one's easy. We started at negative 4. We're going up 3 and over 1. Something like that. Then we started 2 and we're going up 1 over 1. All right, we can see right there is a solution, which is 3, 5. And we're done.
That's pretty neat.
All right, now, this one's a little tougher. We need to subtract x from both sides. That gives me negative 3y equals a negative x plus 2. Then we divide everything by negative 3. So that way we only have one y left. So if I divide everything by negative 3, negative 3y divided by negative 3 is 1y. Negative 1 divided by negative 3 is a positive 1/3. And then we have the x out to the side. Because negative 1 over negative 3, if you have a negative in the top and the bottom, it becomes positive. Finally, 2 divided by negative 3 is just negative 2 over 3. So there's my first equation. For my second equation, I want to get rid of the negative 3x. So I'm going to add 3x to both sides. That'll give me 9y equals 3x plus a negative 6. Divide everything by 9. If you divide everything by 9, you get 1y is equal to 1/3 x plus a negative 2/3. Now, what do you notice about our two equations?
They are almost the same.
Almost?
Yep.
What's different?
Negative.
Two.
What's
One's
negative?
negative. The 1 and 2. One is 1/3 and the other one's 2/3. So
I have y equals 1/3 x plus negative 2/3. And then I have y equals 1/3 x plus negative 2/3. They're the exact same equation. So if I graph the first line, and then I graph the second line, I'm going to graph it right on top of the other one, right? Which means it's going to intersect at every single point forever and ever and ever, which means there is an infinite number of solutions. That's what you'll put, an infinite number of solutions. Okay, so an infinity sign. Now,
Because they're together.
again, let's say you graphed
together.
that line right there, and then you came back and graphed that line right there. What can you tell me about those two lines?
Parallel.
They're parallel.
They're never gonna cross each other.
So that would be no solution. All right. There you go. That's systems of equations. Not too bad.